Okay, I'm back, and now we want to talk about sedimentary rocks. And we said that a sedimentary rock comes from sediments. So when you take any kind of a rock, doesn't have to be igneous, but you take any kind of a rock and you subject it to weathering, and then you glue the pieces parts back together again, we lithify them, then that's going to be a sedimentary rock. So notice that sedimentary rocks tend to form at the surface of the earth, whereas the igneous rocks tend to form deeper inside the earth. So under surface pressures and temperatures, sedimentary rocks are going to be the most stable. How will we classify them? Well, do you notice it's very similar to how we classified an igneous rock? We can classify a sedimentary rock by what minerals are in the rock. So we said that limestone is composed of the mineral calcite. Another one is called chert, and we have a lot of that around here in the Ozarks. The Indians used to use chert to make their arrowheads with because it's very sharp. And so chert is composed of the mineral quartz. Okay, then texture. So in the same way that we could classify an igneous rock by does it have crystals or does it not have crystals, we can classify a sedimentary rock by the size of the particles that makes it up. So that first one there is called a conglomerate, and it is composed of pieces of rock that are about the size of a pebble, and they're all glued together. But look at sandstone. So sandstone is a sedimentary rock that is composed of pieces of material that are sand-grained size and are glued together. So again, that's one way of classifying sedimentary rocks. So if you're one of my students, what would be the sedimentary rocks that you would need to know for the exam? Definitely limestone, because limestone is going to explain what happens to carbon dioxide in the atmosphere. Okay, let's take a look at metamorphic rocks. So think about what does, when a butterfly metamorphosizes, what does that mean? It means it changes. So when we take any kind of rock, so that could be an igneous rock, it could be a sedimentary rock, it could be another metamorphic rock. So you take any kind of a rock and you subject it to heat or pressure or hot water, hot fluids, you can metamorphosize a rock. You can change it. But we do not want to apply so much heat that it melts, because if it melted and then re-solidifies, it would be what kind of rock? Okay, it would be an igneous rock. So we just want to either squeeze it or heat it or put hot liquids through it enough to where we alter the minerals that were in the original rock. And so we can classify them by what minerals are inside the rock. So there's a type of metamorphic rock called greenstone, and it has the mineral serpentine in it. And then you also have the metamorphic rock quartzite, and it has quartz in it. So where do you think quartzite came from? Quartzite had to have come from a rock that had a lot of quartz in it. What would that be? Sandstone. So if you take sandstone, which is a sedimentary rock, and then you subject it to heat, what will happen is those individual little grains of sand are going to start to glue together, and then you end up with quartzite. Another way of identifying a metamorphic rock is how does it form. So marble forms from heat, as does quartzite. And what marble is it's metamorphosized limestone. So if you heat limestone up, it will turn into marble. And then also pressure can do it. So if you look at that next one over, that's called gneiss. So it's not gneiss, it's going to be nice. It's nice, okay? So do you see that it's got those bands? So you might be looking at the bands in the gneiss, and you might be thinking that those are layers, like you have layers of sand in a sedimentary rock, but they're not. So what happens is, this is going to be called foliation, and what happens is the crystals under the pressure actually turn and they make these layers. Okay, don't worry about that for purposes of the exam, but that was called foliation. And so if you take granite and you subject it to heat and pressure, the crystals will start to realign and you end up with the metamorphic rock gneiss. Now, for purposes of the exam, I'm not going to ask you for any of the metamorphic rocks. So you don't need to know the names of any metamorphic rock, but you should know where they come from. Okay, now let's put this all together and talk about the rock cycle. So the rock cycle is going to be how you start with one type of rock and you turn it into another kind of rock. So let's start with an igneous rock. And you take the igneous rock and you subject it to rain and ice and water. And so what's going to happen is it's going to break apart into sediments. The sediments are going to be transported to an ocean or a lake or someplace where they settle out and then are glued together to make a sedimentary rock. Now, what happens if you take the sedimentary rock and you heat it, but you don't melt it? It would then turn into a metamorphic rock. And if you took that metamorphic rock and you continued to heat it, you would melt it completely, and then it would turn back into an igneous rock. So you might get the idea that igneous always turns into sedimentary, sedimentary turns into metamorphic, and then metamorphic turns back into igneous. No, it's not true. Because let's say that you've got a sedimentary rock and you overheated it. So if you really heated it up, it would liquefy and then it would turn back into an igneous rock. So we could go backwards. You could take a metamorphic rock and subject it to water and ice and wind, and you could break it apart, and then those parts could be glued together and turn into a sedimentary rock. So notice that given the right temperatures and pressures and minerals, you can basically turn any kind of rock into any other kind of rock. And so this is going to be called the rock cycle. So you definitely need to know the rock cycle. Okay, in our next segment, we are going to start talking about the Earth and why it is hot.